Welcome to the project demonstration of single phasing preventer for protection of three-phase loads along with temperature protection. So the main application of this project is, we are going to protect the three-phase loads. So we are representing these 6 bulbs as a three-phase loads, as in this one 2 bulbs parallelly connected to this single relay. So like that 3 phases are connected with the 6 bulbs, and that will be controlled through 3 relays, as the 3 relays representing to control the 3-phase loads directly with the 3-phase inputs. And whenever the fault occurred, single phasing preventer, nothing but whenever single phase fault occurred while we are sending a power supply of 3-phase to the 3-phase load, so that will be continuously monitored by these switches. As our microcontroller handled with only DC power source, that's why we are making use of these 3 voltage sensing circuits. So they are directly reducing the 230 volts of AC, whether it is a single phase or 3-phase. For demonstration purpose, we are converting a single phase to 3-phase inputs directly parallelly, and that will reduce the 230 volts AC to 5 volts of DC outputs. Whenever the respective phase is available, then it will provide as a 5 volts DC, so that microcontroller will continuously check the output from these 3 circuits. So if is there any one of the circuits providing a 0 volts, that is indication of single phasing fault, nothing but in the 3 phases one single phase got fault occurred. So that in order to protect these 3-phase loads, we are going to isolate this power supply to the loads by offing these 3 electromagnetic relays. And one more protection is temperature. So if is there any high temperature occurred at this load section, then we are going to preventing that from thermal protection using this temperature sensor and the same relays. Means 2 main inputs to the system, that is single phase continuously checking purpose using the circuits. So we are manually making a fault. Instead of disconnecting the single phase, same we are disconnecting the single phase to the 3-phase load using the switches. Or if is any temperature fault occurred, so due to these 3 abnormal cases, the system will disconnect the power supply to the 3 phases with the help of this electromagnetic relays, and we can get the visual indication on this LED indication board directly which phase got fault occurred. So to execute these features, mainly we are using the 3-phase checking circuits and the switches input to isolate the making the fault of single phasing, and 3 electromagnetic relays for controlling the 3-phase loads, and temperature thermistor and LED indication, and the main PIC16F72 microcontroller, which is the main brain of our system to control the loads. So let us check with the demonstration. So these are 2 power supplies. One is our main processing power supply, and the next which is the input of 230 volts AC inputs. So whenever everything is normal, then the system will switch on the relays, as we can see the LED indication on the relay board also, and total 6 bulbs will get the power supply. So if is there any fault occurred in the single phasing, then automatically the power supply will be disconnected to the total 3 phases, nothing but the 3-phase load will be disconnected from the input power supply. And Y fault, and next red fault. So for every fault we can see the visual indication on this LED board also. And if is any temperature increased, then thermal protection will be occurred, right? As you can see, the light indication on the temperature sensor will show the status of temperature or increased the threshold value, and when it is normal again, this particular light will be off. You can see this, the blue light has got switched off and the relays got switched on. So in this manner we are going to provide the single phasing preventer for 3-phase loads along with thermal protection. Thank you.